In the second exercise, we're asked to translate this switch statement. So let's talk about the switch statement first. How does this work in C? So you give this input value k to the switch statement, and then depending on the value of k, we will decide which line to execute. So if k were to be 2, for example, we would execute the case 2, so f equals g minus h. And then the break instruction causes us to jump out of the switch. So if you don't break at the end of a switch, then the switch will continue and check the other cases as well. So in this case, we always have a break. So at the end of each case is a break, meaning we jump to the end, meaning you could also rewrite this code as a long if and an if else or else if for each of these cases would be the same semantics. Now, we've for the translation, they have specified registers in the assignment. So S0 to S5 contains F up and through K. I've put this in the comments. Good tip for writing assembly, please use the comments to explain what you're doing. In regular code, I would say, please write very clear English code so that when you read your code, you know what's going on. Unfortunately, in assembly, that's very, very difficult, if not impossible to do. So you can use comments here to comment your code blocks, to comment what register contain what values and stuff. It's going to make your life a lot easier. So we this was not explicitly asked, but we added some test values here. We set up our registers with some test values, 20, 30, 40, 50 for G, H, I, J. And then K, we initialized K to 3. So if we take those values, case 3 would be executed, F would be I minus J would be negative 10. With this current settings, we would expect the result to be negative 10. All right. Let's now look at what happens in the actual implementation. How did we implement this case? Well, first of all, we will check S5. So S5 contains the K value. So when we start this, we will check the value of K. And the first case is to see if this is 0. So we will compare K to 0. So this instruction, branch not equal, what does instruction do? Well, if S5, so K, is not equal to 0, then jump to case 1. So then we skip the code right here and we immediately jump to case 1. If S5 is not 0, so if we don't have to take this case, then we jump to case 1. Before I go into the case itself, let's see what happens in case 1. In case 1, we load 1 into T0, and then we check if K is equal to T0. So if K is equal to 1. If not, case 2. Then we do the same thing, but then for 2. If it's not equal, we go to case 3. Then we do the same thing, and we check for the value 3. If K is equal to 3, if it's not equal to 3, jump to the end. Notice that we jump to an empty label. That's perfectly acceptable. Your program execution will just end right here. So the correct way of ending a program in RARS will be with a system call, but we will learn that in the future. For now, you can just let the code end at the end, like this. So if we enter a value for K, for example, 100, nothing of these cases, what should happen is we should jump over the entire switch and do nothing. So, and this is actually what happens here. So let's say K was 100, you'd jump to case 1, jump to case 2, jump to case 3, jump to end, and you wouldn't have done anything. So that's correct behavior. And then whenever we reached either 0, 1, 2, or 3 for the value of K, these cases would have not jumped to the next case, and then all the bodies here, the adds or the subs and J, those would have been executed. Now, what we can see here is the first case, how we implemented it now. So let's go to the implementations of the cases. Case 0 has to add I to j. I is an S3, j is an S4. Adding I to j means adding S3 to S4. The result we store in S0. Why? Because the result is stored in f, and f is mapped to S0. So this is literally f equals I plus j, translation. And then when we're done, this jump end, this is the break statement. If there were no break statement here, we wouldn't have this jump statement either. If we remove the break, we remove the jump, and we simply check the next case as well. But because we have a break, that means jump to the end of the switch, so we jump to the end. And each case now is similar. We simply implemented the add or the subtraction, depending on which case we are in, with one instruction, and then we jump to the end. And that's the full result. Now if we execute this for k is 3 with these values, we should get a negative 10 result. Let's check that. We assemble this. Right now, all of these are simply in registers, so we just have to check our registers. Right here. So what are the relevant registers right now? S1, we haven't executed anything yet, so there's no values in there yet. If we execute this, we will see S0, the result f is negative 10. So we can conclude that our program executed correctly. You could single step through this if you're having problems, but that's it for exercise 2.